So we're going to deal right now with 3-1 alpha, and this is not on the test, meaning what? We're dealing with bivariate data starting today. Chapter 2 is univariate data. Well, what are you talking about? Univariate data means all the data fits in one list. Bivariate data, we're going to have to use two lists. And there is a name for this, statistically speaking. So we don't talk about X and Y variables anymore. In Algebra 2, you moved on to the dependent, the Y value being dependent, and the input, the X value, being independent. Instead, in statistics, we refer to the explanatory and response variables. So there are vocabulary words that are going to come up in the textbook. Now, kind of, you can figure it out. Like the response is the output, yes? So the explanatory is the input. That's the language of the course. And what we're doing here with bivariate data is we're going to use a scatter plot. Stat plot. We're going to, plot it against axes. So first thing is I want to call this distinction out to you. And I told you, describe is a code word. And you're going to get this code word on the AP test. But I made this point a little too well a few years ago. Ready? I say describe, you say center shape spread. Center shape variability. Except that's for data that fits in one list. And that's what your assessment's on Wednesday. But starting today, we're dealing with bivariate data. So if the prompt is described for bivariate data, there are three different responses. Well, two of them are different. Ready? Shape is the same. Shape is the same, whether it's univariate or bivariate. Except in shape, instead of talking about symmetric or skewed, we talk about linear or curved. Centers out, spreads out. Instead, we talk about direction. Are the values going up? Are they trending up? Are they trending down? And we talk about strength. Weak, moderate, strong. And, well, how can I tell the difference? There is no quantitative way. If the answer is strong and you say moderate, you'd be fine. Other way around, you'd be fine. If the answer is weak and you say strong, you're going to have a problem. Now, somebody brought this up to me, and yeah, I was neglectful. When we're dealing with univariate data, and it says describe, you also should mention any outliers. So this is from chapter 2. Center shape spread, identify an outlier if they're in the data set. Okay, now, when you get to the AP test, and it said describe, and you omitted outliers, you forgot, you just went center shape and spread, your grade would be an E. And in the statistics exam, the problems are graded holistically, meaning it's either essentially correct, partially correct, or incorrect. So you could get full credit even if you had a blemish. It would be essentially correct. But, to have the total correct answer for univariate data, yes, you should include outliers. So I don't recall who brought that up to me, but they were correct. And that was good. They were reading the textbook to detail. All right? So you have two lists. The prompt is described. Trend, shape, strength. All right? And you don't have to name them. You can just say positive, linear, moderate. That would be the answer. Anytime, any energy you spend writing a paragraph is not helpful. So we measure linear. If it's linear, we measure the association with correlation. Correlation is the R score. Now, you've seen this in Algebra 2. You've seen it in pre-calc. But what's different is, in this course, we're going to show you where the R calculation comes from. You're not just getting a value as an output on your calculator. But we're going to start slow with a reminder of the Algebra 2 pre-calc material, which is this. The SIGN of R has nothing to do with the strength. The closer you are to 1 or -1, the stronger your correlation is. The SIGN of R only identifies whether the direction, whether the graph is going down or going up, whether the slope is positive or negative. So it's linear. If the slope is positive, R will be positive. If the slope is negative, R will be negative. So if you got a question that said, what's a higher correlation? -7/10 or +6/10? Well, the answer would be the -7/10, because that's closer to 1, the absolute value of -1, than it is to than 6/10 is. All right? And just because you have correlation, that does not imply causation. So we have to start somewhere. So we want to see if two variables are correlated, but that doesn't mean that one causes the other. And the only way to do that is to do an experiment. We have to do that. That's part of things we'll get to later. Okay, but it's important that you realize that just because two things are correlated does not mean that one caused the other. Okay, so we're going to take you to page 161 in the textbook. I think it's probably better if I bring it up here since we're filming this. If I can get to page 161 efficiently. That's actually pretty good for me. So on page 161, you have this picture. I just lost it. You have this picture, okay? And this is something that you have to be able to do. So make sure this makes sense to you. This picture right here, the northwest, that's what the correlation of 0 looks like. The input and the output do not, the line of best fit would be horizontal. There's no correlation between those two. This one right here is negative. Now, it's not real, ready? They're telling us it's -3/10. So I would describe this as linear, negative, weak. This one, linear, positive, weak. Down here, linear, negative, strong. If you wrote moderate for this one, that's fine. If you wrote moderate for that one, that's fine. This one's certainly weak. Linear, positive, strong. Linear, negative, strong. Okay? So we're going to go to a couple questions that have to do with the same data set. So we're going to do problems 3 and 7 on page 171. I'm going to pause the video and we're going to come back to, I didn't record this. Ouch, too late. So it costs more money to park for a Phillies playoff game than it did for a regular season game. Now the stadium's, relatively empty, even, last year and so. So my advice to the Phillies owners are raise the parking rates. If you raise the parking rates, more people come to the games. But that's simple because that's not causing the attendance to go up. Okay? So I'm actually going to keep the recording going because I left out problem 3 and 7. I'm going to go back to that, but you don't need to stick around for that. So give me a couple minutes to finish going over 3 and 7, and then I will send out the exit ticket, and tomorrow we will meet at for 15 minutes at 10:10. Okay? So thanks. You're dismissed. Hopefully we can get these Chromebook issues resolved. So, as I said, come back to problem 3. 3 is the scatter plot of the weights of these children, and that's in list 1, and the weights of the backpack is in list 2. So I just went here, on the calculator, to second y equals, turned on the stat plot, turn it on and pick this type, it's a scatter plot. And it looks like, ready? I want a window for this picture. So it looks like for the window, I looked at these weights for the children, and the lowest weight was 103, and the highest weight was 187. So I just stretched those. So I made the lowest value here on the x-axis 100, and the highest 200. And then it looks like that the scale is 20. So there's 120, 140, 160, 180, 200. And for the backpacks, the lowest backpack looks like it's 24 pounds, and the highest looks like it's 35 pounds. So it looks like I went from 20 to 40 with everything, the scale being 5. So 25, 30, 35, 40, and you get this picture. And the prompt describe, you would look at this picture and say, that is positive, it's linear, it's very linear until you get to this point. And that's the kid, the beefiest kid, has kind of a light backpack. But it's really linear until you get there. So positive, linear, strong. And if you said positive, linear, moderate, because of this child's going to bring the slope down, that would be acceptable too. Okay? But you have to be on board with what the prompt is saying. They want the trend, the positive or negative. They want the shape. Is it linear or curved? They want the strength, strong, moderate, or weak. Okay? So that's that for 3-1 alpha.